You are working on a regression problem with a dataset having nonlinear relationships between features and the target variable. You want to apply a technique that utilizes the power of kernels to model these complex relationships. Which of the following methods would you use? A. Linear regression. B. Logistic regression. C. Kernel-ridge regression. D. Decision tree regression. E. All of the above. C. Kernel-ridge regression. Kernel-ridge regression is a powerful technique that extends the concept of ridge regression by introducing kernels. Kernels allow us to implicitly map the data into a higher dimensional space, making it possible to model nonlinear relationships. It's a good choice for handling complex relationships in regression problems, and is particularly effective when the dataset has a high dimensionality. Incorrect. Linear regression assumes a linear relationship between features and the target variable. It cannot effectively model nonlinear relationships. Incorrect. Logistic regression is a classification model used for predicting categorical outcomes, e.g. yes, no, spam, not spam. It is not suitable for regression problems. Correct. Kernel-ridge regression is specifically designed to handle nonlinear relationships by utilizing kernels. Kernels allow the model to implicitly map the data into a higher dimensional space, enabling it to capture complex patterns. Incorrect. While decision tree regression can handle nonlinear relationships, it can be prone to overfitting and is not as flexible as kernel-ridge regression. Incorrect. Only kernel-ridge regression is suitable for the given scenario. Kernel-ridge regression is a type of regularized regression that uses kernel functions to map data into a higher dimensional space. It helps in finding nonlinear relationships between features and the target variable. It's known for its ability to handle high-dimensional data and provide robust predictions. A kernel function measures the similarity between two data points in a higher dimensional space. It helps in capturing complex relationships without explicitly computing the mapping. Common examples include the linear kernel, polynomial kernel, and radial basis function (RBF) kernel. Regularization is a technique used to prevent overfitting in machine learning models. It adds a penalty term to the loss function, encouraging the model to find simpler solutions. It helps the model generalize better to unseen data. Overfitting occurs when a model learns the training data too well, failing to generalize to new data points. This can lead to poor predictions on unseen data. Predicting housing prices based on various features, e.g., size, location, amenities. Estimating stock prices based on historical data and economic indicators. Predicting customer churn based on their behavior and demographics. Forecasting sales based on seasonal patterns, marketing campaigns, and economic trends. Analyzing the relationship between air quality and health outcomes. Let's consider a simple example where we want to predict house prices based on their size. We have a dataset with two features: size in square feet and price in thousands of dollars. We use the RBF kernel in kernel-ridge regression to find the nonlinear relationship between size and price. 1,000, 1,500, 2,000, 2,500, 3,000, 150, 220, 300, 380, 450. The RBF kernel will map the data into a higher dimensional space where a nonlinear relationship can be captured. Kernel-ridge regression will find a function that best fits the data in this transformed space, allowing us to predict prices for houses with different sizes. The regularization parameter in kernel-ridge regression helps to prevent overfitting, ensuring that the model generalizes well to unseen data. From sklearn, kernel-ridge import kernel-ridge Model kernelridge alpha 0.1. Kernel RBF. Model FitX train. Y train. YPRED model. PredictX test.